technology is the canvas where human imagination paints the future. A very warm welcome to the very first episode of Season 5 of Tech Innovator, proudly presented by IEEE TechVerse Sri Lanka. After 4 successful seasons of uncovering industry secrets, exploring the latest tech trends, and showcasing innovations that are reshaping our world, we are thrilled to kick off this brand new season. Tech Innovator is not just a tech series, it's a platform for curious minds and passionate enthusiasts to dive deeper into the ever-evolving world of technology. I'm Likitha Chathubhashini and I'll be my moderator for today. Today we are incredibly honored to be joined by a distinguished guest, someone whose work continues to inspire and influence the tech landscape. He will be sharing invaluable insights, practical knowledge, and his unique perspective on the future of technology. So buckle up and get ready for a captivating ride, and filled with innovation, inspiration, and infinite imagination. Let's move on to our session. First of all, let me introduce our incredible guide for today, Mr. Liyanage Akash Tharuka Perera. He's a lecturer at the Department of Computer Systems Engineering, University of California. With nearly 3 years of teaching experience, he also served as the advisor for IEEE Computer Society Student Branch Chapter. Currently, he is pursuing his master's degree in computer science at the University of Colombo School of Computing. His research interest focuses on artificial intelligence, the Internet of Things, and especially on computer networks, including software-defined networking. He is passionate about exploring how emerging technologies can drive innovation in network systems. So today we are diving into an exciting topic that's transforming how we think about computer networks, software-defined networking, or we call it as SDN. So sir, let's start with the basics. For those watching for the first time who might be new to this topic, what exactly is software-defined networking and how does it differ from traditional networking?
Okay, first of all, thank you so much for having me. It's a real pleasure to be part of this episode of Tech Innovator. And the thing is, SDN or software-defined networking is not just a buzzword. It's a concept that is quietly been transforming how networks operate behind the scenes. So interestingly, SDN isn't brand new. It's not a very novel thing. Its foundation go back over a decade now, around 2009-10, around those days. The foundations were laid at Stafford University by pioneers like Martin Casado, who is often credited as the father of SDN. So now, why do I think SDN is going to be a big deal in the future? Because we are entering an era where networks need to be smarter, or we call it automated. And it should be faster and it should be adaptive. So the thing is, SDN pairs beautifully with AI or artificial intelligence and machine learning. Like imagine network that can detect congestion or threats and fix themselves in real time. So that's where SDN is heading. So now to answer your question, what exactly is SDN and how it is different from traditional networking? Think of traditional networking like driving a manual car, right? You have to control everything, the clutch, the gear, the steering. So in this case, every device, just like routers and switches in a network, handles its own decisions, making the network harder to manage as it grows. You know, when we drive a vehicle for a long period of time, there's going to be different problems that we have to fix. But now SDN is like a switching, or you can say SDN is like switching to a self-driving car with GPS navigation. You set the destination, like if it is a computer network, you are going to mention the network policy, and the centralized brain called the controller figures out the best route and tells all the cars what to do, right? So in short, traditional networks, each device thinks for itself. Everything's done by the device itself. But in SDN, one smart brain, or we call it the controller, tells devices how to behave. So that's the main difference.
Okay, thank you so much for that, such a great explanation. So now SDN is often described as a big shift in how networks are built and managed. So why is SDN considered such a major change in network architecture? And what kind of the benefits does it bring? Also, for our viewers who are trying to visualize this, could you briefly explain the role of the control plane and data plane in SDN as well?
All right. So when it comes to SDN breaks the network into two brains, right? Or you can say two planes actually, or two parts, in other words. The first plane or the first part is the control plane, where the decision maker, that's the decision maker, what should we do? And in the data plane, that's the action taker, just do it, that's it. So in traditional networking, both brains are stuck in each device. So from a single device, you have to control plane, you have to do the controlling part, and then you have to do the action part, data plane. So you can imagine a single device have to do both things. So the amount of utilization you need, amount of resources that you need, amount of heavy lifting a device does. So there are those disadvantages. But with SDN, we extract the control plane and centralize it in one controller. So basically we get the device, we remove the control plane and we send it to a central plane, and we only have the data plane separately. So now the device doesn't have to do a lot of work. So the benefits: centralized control is easier to manage and automate. The flexibility is going to be there. The troubleshooting is going to be very easy, and also the security, right? So like imagine trying to update the rules across 100 routers, because the networks consist of routers. So imagine you have to update rules across 100, how much time it will take. But with SDN, you can change it in one place, the controller, and it updates everywhere. So let's say your campus wants to block TikTok during lecture hours. So sorry, students, but in traditional setup, you either need to manually configure ACS, or we call it access control list, or rules across multiple routers or switches if the traffic bypasses the firewall, or we have to rely on a central firewall. But with SDN, you don't need to redesign your entire network or rely solely on a firewall. You can just push flow rules, block TikTok at the edge switch closest to the user. So we can simply push flow rules to the switch, and the switch will take care about it from there. So that's the biggest advantage.
Yeah. So thank you for breaking that down so clearly. So now we keep hearing about the open flow protocol in SDN discussions. So how does open flow fit into the SDN ecosystem, and why is it so important?
Yes, that's a good question. So open flow is like the universal remote control for SDN, right? It is the protocol that lets the controller talk to the switches and routers. So if you consider SDN controller is the brain, OpenFlow is the nerve system, carrying instructions to and from the devices, and it tells switches things like what packets to forward, where to forward them, whether you need to drop them or mirror them or reroute them. All those things are done by OpenFlow. Why it is important? Because without OpenFlow, SDN would just be a cool idea with no way to execute it. But because of this OpenFlow protocol, now it is possible. So in simple terms, if I say for the viewers that doesn't have a good idea about what it is, OpenFlow is like the waiter between the customer and the kitchen, right? It takes orders, delivers them, and bring back the results. That's it.
Yeah, amazing. So let's bring it close to home now. So in what ways do you think SDN could be useful in Sri Lankan context? Maybe in education networks, telecom, or even government infrastructure?
Actually, plenty of ways. If you take education networks, actually universities can change, or universities can manage labs, guest Wi-Fi, internal networks more efficiently. Like a problem that a lot of universities, even in our faculty, we need to have a control over the network, but still we don't have it. So we can get that control. And like imagining assigning different internet policies to labs for different types of students, like we have masters, PhD students, like for them we have to give different types of access. So we have to write different types of policies, and we have staff. So if we can do all these things from one dashboard, that's what you call convenience. And then telecoms, like they can do real-time network management, traffic optimization, dynamic service deployment, like 5G slicing. The 5G is becoming a big deal in Sri Lanka now. And the government infrastructures, one of the most important things in the country. So the security, right? That's the one of the important things you have to consider when it comes to government infrastructure. The security, disaster recovery, or even smart city networks. So SDN offers centralized visibility for all these aspects. So for an example, I'll give you example as well. So in Sri Lanka, a typical government van project costs around 10 million with dedicated hardware at each site. But with SDN, by using virtualized routers, white box switches, that cost can be simply reduced to 20 to 30%. So that's the advantage we have.
Yeah. So, of course, that with every opportunity comes a set of challenges, right? So, what do you think are the biggest hurdles Sri Lanka might face in adopting SDN widely?
The first thing is actually lack of awareness and training. Because I once reached out to a few industry professionals to run a guest session on SDN for my kids. And most of them had heard of it, but very few had practical experience or confidence to teach it. So that's the gap. So we need more SDN hands-on experience or hands-on exposure in both industry and also in academia as well. So the first problem is lack of awareness and training. And the next one is the legacy hardware, because at the end of the day, like all the devices might not support SDN. That's the truth. And unfortunately, most of the networks still use hardware from the pre-SDN era. That means a lot of government organizations, once they make the network, they don't want to change its infrastructure. That makes sense from their end, because the next challenge or the hurdle is the budget constraint because of that. Because upgrading infrastructure, it requires investment. But the private sector can do it, but the government sector investment need benefit. So the benefit, you can see it's a bit challenging when it comes to government. And another problem that we as academic face when we are actually testing out these technologies is the vendor lock-in. Because some vendors, their solutions are proprietary. That means if you want it to work properly, you have to buy the devices from the same brand. You can see some smartphones have this problem, like you have to buy the same model, then it will work nicely, right? Same problem is there with networking as well. We have the vendor lock-in. So when that happens, it's very hard to do some experiments. So that's a big hurdle as well. So OpenFlow is an open source protocol. That's why it means a big deal to people who's working with SDN. But everything aside, I think the greatest challenge of all, it's not the technology, it's not the budget, or it's not the hardware. It's overcoming the resistance to change itself, because people don't like to change. If the network is good, don't do anything to it, keep it. If it breaks, let's do something to it. So their resistance to the change, I think that is also a big hurdle when it comes to SDN.
Yeah, of course. So it's really interesting that looking at the local landscape. So, and for all the students watching who are curious about future in networking, so what skills should they be focusing on to prepare themselves for a career in SDN, as you think?
Absolutely. So, and this is very important because networking hasn't had a major shift in decades. Like you can see, SDN could be the AI moment for the networking world, because in the software or the data science world, you have this AI moment now, the big boom. But SDN could be the AI moment for networking. So, what do you need to know if you want to prepare your career in SDN? First thing first, networking fundamentals, right? Know your OSI model, what is IP, what is routing, what is switching, know your basics. And programming, very important. So Python is your best friend for SDN scripting. So learn some programming. And be familiar with tools. Like there are tools like Mininet, Wireshark, SDN controllers. So familiarize yourself with those. And then the cloud and virtualization. That's also very important because at the end of the day, most of the time you're going to host a lot of things in the cloud. So SDN and cloud go hand in hand. So you have to learn those things as well. And then the simple soft skills like communication, documentation. These are very underrated in tech, the communication and documentation. With my experience, like when we ask a student to submit a lab report, they hate it, right? But we ask to do it because that practice you to do some documentation, right? It is very important. So these are the things you have to do, like networking fundamentals, programming, tools, cloud, soft skills, right? And also research. That's also very important. So SDN and AI is a hot research area. Like self-healing networks are there, traffic prediction, AI-powered firewalls. So because this is why it matters, because when a student enter the job market, having SDN on their resume makes them stand out. And most companies are still catching up. So this could be the student's chance to lead, not to follow, right? So that's it.
Thank you so much for this awesome advices for our viewers. And now, do you have a real world example or a case study you could share, that something simple where ISDN has clearly improved performance, flexibility, or security in a network?
Yes. Google's B4 network is a classic case. You can search it, the viewers can search it on Google if they're interested. It's Google's B4 network. Because before SDN, before this B4 network, SDN link utilization was around 40%. So it's just to be safe. With SDN, they actually dynamically shifted traffic, pushed policy changes globally within seconds, and achieved near 100% utilization. So from 40 to 100. In their documentations, they say that. And they mentioned that they saved millions of dollars per year. So they're still making money because of those changes. And the backstory was they actually developed their own SDN controller, and they used OpenFlow enabled devices. And it helped Google to improve services like Gmail that we use, YouTube, with better backend network efficiency. And there's a very good prominent example in Sri Lanka as well. The Dialog Broadband Networks, a subsidiary of Dialog Axiata, they launched FlexNet around, I think, back in 2018 or 19, as I remember. That platform actually gave advantages like real-time encryption, smart traffic optimization, centralized software-based control, flexibility, and they introduced a grow-as-you-go model for payments as well. So in Sri Lanka, we are shifting to it. So this was introduced like 5 or 6 years ago. So you can see in the future, we'll see more stories about this. But these are two case studies that I actually saw in documentation as well.
Yeah, so that's super helpful. So, and finally, for students and tech enthusiasts here in Sri Lanka, so are there any tools, platforms, or any simulators that you would recommend they try out for hands-on practice with SDN?
Absolutely, yes. And the good thing is they are actually free as well. There's something called Mininet that emulates SDN networks on your laptop, right? So you can actually emulate the network and test it out. And there's something called RYU. I call it RYU. It's a very beginner-friendly SDN controller, and it is running on Python as well. As I told you, programming is very important. So this is running on Python. And there's another one called POX. It is a very lightweight SDN controller. Lightweight means actually you can run this POX controller in a Raspberry Pi if you want. So you can see Raspberry Pi is a very small computer. So you can run this controller in something like that. So the sky is the limit after that actually. And then you have Wireshark for traffic analysis. And there are different kind of operating systems like ONOS, Open Daylight. And other than that, you can actually get a general networking skill from using tools like Cisco Packet Tracer or GNS3. So there are a lot of actually lots of tools and platforms that you can use to practice.
Yeah. So thank you so much for those platforms and tools as well. So actually, what's an insightful session. That was a huge thank you to Mr. Liyanage Akash Tharuka Perera for sharing his expertise and giving us a deeper understanding of software-defined networking and its potential in shaping the future of digital infrastructure, both globally right here in Sri Lanka. So from its architectural advantages to real-world applications, so SDN is truly defining how we think about networks. And for all our aspiring tech innovators out there, we hope this conversation sparked new curiosity and motivation to dive deeper into this exciting field. So if you enjoyed today's session, don't forget to like, share, and comment down below. And also follow IEEE TechVerse Sri Lanka for more inspired discussions, tech trends, and expert insights. Until next time, keep in mind that technology is the canvas where human imagination paints the future. This is Likitha Chathubhashini signing off from Tech Innovador. Stay curious, stay connected. Thank you.